All right, so let's check out some practice 6.3 and start with the first one. Use the information given to answer A, B, and C. So we have theta lies in quadrant 2. And we're told in this quadrant what sine theta equals. And you want to remember sine y over r. So that means 5 is the y part, and 11 is the hypotenuse. And then we can use Pythagorean theorem to get the other piece. Was that 96? And then we get a plus and minus solution, and we take the square root. And we're going to look at our right triangle then, and we can see it's in the negative x direction, and so we're going to choose the negative root there. So for sine 2 theta, we'll take a look at our identity sheet for double angle identities, since that's what we have here. So sine 2x. So we know that for A, we know that sine 2 theta is 2 sine theta cosine theta. And we're given sine theta. That's 5 over 11. And cosine theta we can now get from our right triangle, since cosine theta is x over r, and x is what we just found, and r is the hypotenuse. And MyMathLab does say type an exact answer using radicals as needed, so not going to use a calculator here. So 2 times 5 gives us a 10. $11 times 11. And MyMathLab will probably want that 96 simplified. So 96 is 16 times 6. The square root of 16 is 4. So we get 4 square root of 6 over 121 to get then a minus 40. So for part B, we're going to want a double identity for cosine. So we have here. And we get the 3 for cosine, 2x. And let's choose the simplest one. Sine is what's given to us. And so it's up to you on which one you want to use. But I'm going to go with the last one there. Of cosine 2 theta, 1 minus 2 sine squared theta. Sine squared theta. And because sine is given to us, at least in science, usually you want to use what's given to you before you use numbers that you calculate from that. And I get a sense There might be, no, there isn't. Might be a common factor there. Let's see. And then for tangent, we'll get one choice. And I'm just going to write that one down fast. So tangent, going to take a little bit more work. Since we don't know what that is yet, but we can get it from our right triangle. So looking for tangent from our right triangle, where we know x was minus square root of 96, tangent being y over x. And so y is 5 and then x. Now my math app does say rationalize the denominator, so I'll have to be careful about that square root down there. But let's take this, plug it in to our tangent formula. And getting a common denominator in the bottom here. And so we have and division by fraction, the same thing as multiplying by the reciprocal. And can I squeeze this in right here? So remember, the square root means to a power half, and this is power 1. And when you have these in division, you subtract the exponents. So these 96s simplify when you have the through division by subtracting these exponents. So 1 minus a half will give us a half all over 71 there. Not a quick, oh, because 96, that's right, is, what was that again? 16 times 6, and the square root of 16 is 4, so we get 4 square root of 6 over 71. So they're actually looking here for minus 40 square root of 6. And that is the first one. So doing this again with different information. Cotangent lies in quadrant 3. And cotangent, so tangent is y over x, and cotangent is the reciprocal of that. So we can interpret this as being 3 over 1. So looking at our right triangle, the x component is 3, y is 1. Notice both of these are in the negative direction, So this is actually -3 and -1. And of course, the negative will get us a +3. And since we know we're going to need sine and cosine, let's just do them quick. So we're going to need the Pythagorean theorem. And hypotenuse, always considered positive. So sine is y over r, and cosine is x over r, and tangent is y over x. So looking at A, sine of 2 theta is 2 sine theta cosine theta. And we'll plug in our info. For sine 2 theta. And cosine. So they gave us cotangent. None of the cosine expressions actually have a cotangent in them. So in this line here, and doesn't matter which one we use. I'll go with the cosine when it's time. I usually don't go with cosine squared minus sine squared because that's more work. You have to plug in both of those things. So I usually choose one of the last two myself. That's not always the case, though. Sometimes you may have to use that first one. And we have this information. So cosine theta and finally, the one that's usually the longest, the tangent. And that one I don't always quite remember. We look at that one again. And we'll look back at our right triangle because we have a tangent there. It's 1/3. And division is the same as multiplying by the reciprocal. So we'll get some cancellation here. 9 divided by 3 is 3. And 2 goes in 8 4 times. And there is question 2. All right, so they want us to find the exact values here. And notice what they're giving us. They're giving us this expression. This is what they're giving us, where we identify theta here then as 22.5. Now this is a double angle identity for sine 2 theta. And we just identified what theta is. So this must equal twice that, which is 45. And sine of 45. And we're choosing this one. And there's number 3. Number 4, similar deal. Recognize what they're giving us. This expression, where we identify then theta as 5 pi over 8. And this expression is the double angle identity. And there is the angle, which means this is twice that. So you can do 2 times 5 to get 10, but this 2 will also cancel out this 8 here. So 2 goes in 8 4 times. So this actually will reduce to 5 pi over 4, which has a reference angle of pi over 4. So cosine of pi over 4 is square root of 2 over 2. But 5 pi over 4 is in the third quadrant. And in the third quadrant, cosine is negative because it's going in a negative x direction. So cosine 5 pi over 4 then is negative square root of 2 over 2. And there's number 4. All right, so the verifying the identities. So normally there's a lot of approaches you can do, but for MyMathLab to grade us, we have to follow their approach, which can be challenging, which is an extra challenge to these problems, figure out what they want us to do. So for instance, in this case, they want us to use a double angle formula for cosine 2t. Well, if we look at cosine 2t, it's got 3 choices. And only one of them is the one MyMathLab wants. And pretty much you may just come down to having to check each one and see which one it wants. However, if you want to see more of the math, try to predict with the math, the real sign here is that you have sine 2t, the real signal, the flag, sine 2t, which is another double angle. And sine 2t is 2 sine cosine, which means we expect the right side to somehow get to be a 2 sine cosine. So for instance, if we choose the first one, that's cosine squared minus sine squared, And we recognize that cotangent is cosine over sine. And we distribute this we don't see that we're getting any closer to 2 sine x cosine x. It's just getting more complicated. Now we could try the second one, but actually it turns out to be the third one. So remember, cotangent is cosine over sine. And we're going to use the third identity here, 1 minus 2. Now, why is this good? Well, the 2 here is something we would expect with the 2 sine x cosine x. And if we distribute this into the parentheses, one of these signs will cancel, and so we'll have 2 sine cosine, which is what we're looking for. And it's this third identity that will get us that. So this is kind of our sign here then. Okay, this is looking good because we know 2 sine cosine is going to be that 2t we're looking for on the left side here. And of course, cosine over sine is cotangent. So this actually proves it right here. So let's see what MyMathLab expects to see here. So that's the identity we're plugging in. Distribute. Okay, so they just want us to distribute. All right. And then the expression simplifies by using quotient identities. So this right here, going from cotangent to cosine over sine, that's the quotient identity, what that's called. And there is number 7. All right, so power reducing. And what that means is since our power reducing formulas are all in something squared, sine, cosine, and tangent, means we want to write sine squared squared. And then we can use the power reducing formula on a sine squared on the inner parentheses. So just looking over here to the power reducing identity. And all that is squared, so 1/2 squared is a 4th, and a 4th times 5 is 5/4. Now, MyMathLab wants us to write the final answer with trig functions having a power no greater than 1. And right here, if we distribute this, we get a cosine squared. And they want us to get rid of that. So if we distribute this, minus cosine 2x minus cosine 2x is minus 2 cosine 2x, and minus cosine 2x times minus cosine 2x is positive cosine 2x, and that is squared. And here is our squared that they want us to get rid of, and that's what we have to do. Why? Because that's what they want. There's really no math reason to do this. It's just what they want. Practice using these manipulations is really what this is ultimately about. So looking at the power reducing identity cosine squared, now you have to remember that we're going to put in a 2x here. We're going to put in a 2x into something that's already a 2x. So we'll get a 2 times 2 is a 4 there. So what I'm saying for cosine squared 2x, this is 1/2 1 plus cosine 2x. 1 plus cosine 2 times what we're putting in. So the x on the Word document is not the same x as you write on your paper. These are different x's. The Word document means this for x. So on the Word document here, you're plugging in 2x, and then that's times 2 again to get you 4x. And we'll just do whatever cleanup there is, and that's just distributing here. So 1/2, you have a 1 over here, so 1 minus 1/2 is 1/2. Or wait a minute, minus. That's 1 plus 1/2, so that's 3/2. And then minus 2 cosine 2x, and then 1/2 times cosine 4x, and now all the trig functions are written in power 1. It's not in the correct form. Oh, I guess they are. Yeah, we do have a 1/2 in here. We can pull out. Actually, is another GCF here. Pulling out the 1/2. 1/2 times 5/4, 5/8. Pulling a 1/2 out from here is 3. Pulling a 1/2 out from 2, well, I don't know if this is what they expect, but we'll see, is actually going to be 4. So you can check that again if you distribute a 1/2 into the parentheses here. So a 1/2 times 3 is 3/2. A 1/2 times 4 is 2. And a 1/2 times 1 is a 1/2. Is this what they expect? It is. All right. I mean, it does say use fractions or fractions. So can't say why this answer was preferred over what I have, but it is what it is. Whoever programmed it that day decided so. So half angle. And looking at our half angle identities over here. So for sine. Now remember here, the half angle is written as x over 2. And what we're saying is these equal, because we're saying it's a half angle. That's the problem is stating it, use a half angle. So that's how we can get to this equality, which we then identify 15 as being x over 2, which means then x is 30. So we have sine of 15, which is x over 2, which is 30, equals plus or minus. So I'm just looking at the right Word document for half angles. And now it says cosine x, where x is 30. Cosine 30. And we can combine this because 1 is 2 over 2. And in the denominator, 2 times 2 is 4. And the square root of 1/4, square root of 1 is 1, square root of 4 is 2. We've simplified as far as we can go. And I usually do as the last step, choose the plus or minus sign. So find sine 15 is first quadrant. And in the first quadrant, sine is positive. All right, so final half angle. Now remember, they're stating to us that this is a half angle, to use a half angle. So we identify 165 as x over 2, multiply both sides by 2. And we need to use a half angle formula. Tangent has 3. I'm going to use the square root one because then we only have to figure out cosine. The other two require sine and cosine. So we need cosine. We'll need a right triangle to figure that out. And to get the right triangle, we'll need the reference angle. So 330 is going to be all the way. Quadrant 4. 330 gives us a 30-degree reference angle. And tangent 30. And then we recognize tangent as y over x. So y is square root of 3. And x is 3. Now that's for tangent 30. But we can see in the fourth quadrant here that square root of minus 3 is actually going to be negative 4 tangent 330. So let's look at the half angle. So, well, from this we can get cosine. So that was the whole purpose of the right triangle. To get cosine, we are going to need the hypotenuse. So Pythagorean theorem that. And 12 is 4 times 3, square root of 4. So that's our hypotenuse, which means cosine then of 330 So again, just looking at our right triangle to get that. So looking at the half angle for tangent. So tangent of 165 is equal to plus or minus the square root of 1 minus cosine. Remember, this is cosine x now. That's cosine 330. And cosine 330 is what we just figured out. That's over 1 plus cosine 330. All of this is under the square root there. And we're going to need to clean that up. So in the numerator, we're going to need to combine these with a 2 square root of 3. So I did a common denominator here. 2 square root of 3 is a common denominator, so you multiply 1 by that. So you get 2 square root of 3 minus 3 over the common denominator. Same thing in the denominator. And division is the same thing as multiplying by the reciprocal. So those 2 square root of 3's will cancel. And then tangent of 165. That is second quadrant. In the second quadrant, y is positive, but x is negative, which means tangent is negative. So we choose the negative answer. And they do want us to rationalize the denominator. Oh boy, because we do have a square root in the denominator. So that will further mean we have to complex conjugate this. So if you recall the complex conjugate, if we want to get rid of a square root in the denominator, We multiply by the same thing, but switch the sign. That comes from the difference in squares that we're able to do that. And in the numerator, we have to distribute all of this. So these two together, 2 times 2 is 4. Square root of 3 times square root of 3 is 3. And then we have minus 3 times 2. And then again, another minus 3 times 2. And minus 3 minus 3. And then in the denominator, 2 times 2. This is going to be a minus and plus, we'll subtract out. Plus and minus 3 is minus 9. Twelve and 9. A 3 will still divide out here. 21 divided by 3. 12 divided by 3. And holy cow. There it is. Not in the correct form. What? I rationalized the denominator. Well, I am on a loss on that. How is that not in the correct form? All right. That may be true, but will require a couple more exponential steps there. Well, if you email me this, I would definitely give you full points if you entered it what I entered in, because that's a whole nother ball game to get this answer to the one they want. Granted, theirs looks nicer. I'll give them that. But if this happens to you, send it to me. I'll give you full credit. So there we go. Homework 6.3.